Why there are two tides. Most coastlines get 2 high tides a day, not 1. If tides were simply the moon pulling the sea towards it, there would be 1. The reason there are 2 is that the moon pulls on everything, not only the water. It pulls hardest on the side of the earth nearest to it, less hard on the solid center of the earth, and least hard on the far side. So the water on the near side is pulled towards the moon more strongly than the planet is, and it rises. And the planet is pulled away from the water on the far side more strongly than that water is, so that water is effectively left behind, and it rises too. The result is 2 bulges on opposite sides, and the earth turning underneath them. Any given coast passes through both in a day. The sun does the same thing, at about half the strength, and the 2 effects add or cancel. When the sun and the moon line up, the tides are large. When they are at right angles, the tides are small. The pattern was described mathematically in the 1680s. The underlying idea that the sea is following the moon is very much older than that. The moon is getting smaller. The moon has been cooling since it formed, and cooling things contract. Over the last several 100 million years, the moon has shrunk by more than about 50 meters across. That sounds like nothing on an object more than 3,000 kilometers wide. The interesting part is what shrinking does to a brittle crust. It cracks. Specifically, the surface breaks along thrust faults, where one slab of crust is pushed up over the slab beside it, leaving a low step across the landscape. Spacecraft photographs of the surface have found thousands of these steps, scattered all over the moon. They are also young. Some of them cut across small craters that are themselves recent, and they have not been softened by the slow rain of micrometeorites that wears everything down. That means the faulting did not stop long ago. It is still going on, which makes the moon geologically active in a modest and very slow way. Not volcanoes, and not moving continents. Just a world that is still settling, cracking as it cools, several billion years after it formed. The quakes. Between 1969 and 1972, crews left seismometers on the surface at 5 different sites. 4 of them kept working and kept sending data until they were switched off in 1977. In those years, they recorded thousands of events. They fall into a few kinds. There are deep moonquakes, several hundred kilometers down, and these are tidal. They cluster in time with the moon's orbit, which means the Earth's pull is what sets them off. There are impacts, meteorites arriving. There is thermal cracking, the surface flexing as the 14-day night ends and the sunlight returns. And there are shallow moonquakes, which are the interesting ones. They are rare, and some of them were strong, around magnitude 5, which on Earth is enough to be alarming indoors. There is one more thing the seismometers showed, and it surprised people at the time. A moonquake on the moon does not stop the way an earthquake stops here. The signal rings on for a long time, in some cases well over an hour. The dry, fractured, uncompacted outer layers scatter the energy instead of absorbing it, so it rattles around rather than dying away.